All right, 7.2 is on verifying trig identities. So that's the only thing we're going to do for this section. So you should learn just to verify trig identities. All right, the book gives some steps for verifying trig identities. It says work with one side at a time, which is what we're going to do. And we usually start with a more complicated side. Okay, we're going to look for opportunities to factor, to add fractions, to square a binomial, things like that. We're also going to look to put things in terms of sine and cosine. And we're going to just, when we don't know what to do, we'll just try something. And if that doesn't work, we'll try something else. We don't always have the end in mind, but we just have to start down the journey of rearranging and simplifying and try to get the more complicated side to look like the more simplified side. So let me just do one example, and then we'll do some homework problems. Here's an example here where we have secant squared of theta minus 1 over secant squared of theta, and we know it's going to equal sine squared of theta because we're verifying this identity. So we're going to start with the left-hand side here, and we're going to try to simplify it. So now on your formula sheet, you guys are going to notice under Chapter 7, it actually might be under Chapter 6 on your formula sheet depending on how updated it is, but Chapter 7, you'll see these trig identities here that we used in 7.1. And one of them has a relationship with secant here. If we were to subtract 1, we'd have secant squared minus 1 equals tangent squared. So secant squared minus 1 is really tangent squared right here. So I can write this as tangent squared of theta over secant squared of theta. Now, I'm going to simplify this more, so I'm going to rewrite this now as tangent's really sine squared over cosine squared. And I'm dividing that by the secant, which is 1 over cosine, so be 1 over cosine squared. I'm going to move this to the top and multiply by cosine squared of theta. And these should both be squared because tangent squared. So now I have this, and these cancel, and I just get sine squared of theta. So what I did is I started with the left-hand side, I simplified the left-hand side, worked this way, and went down and got this. So what I did is I proved that the left side of the equation does equal sine squared. So it's actually my work that I need to show here. My work right here is the solution. It is the answer that we're looking for. This is the verification of the identity. So this is what I'm going to be looking for on the test. I am going to have to read your work, so make sure you show it clearly. It would have been nice if I would have went straight down if I had enough room. I could have went down further. But I should be able to follow your work as long as you write it clearly like this. Let's try some homework problems like this, and we'll get a lot more practice.